Something special is happening at Lenovo's Mooresville campus that has ramifications for businesses and consumers across the world.
I'm thrilled to announce that we've released our first phase of our Lenovo Nokia validated design, targeted for AI data center deployments. This validated design removes barriers for customers across service provider and enterprise to deploy and monetize AI.
Lenovo and Nokia partnered to design, build, test, and validate a sovereign AI data center blueprint solution. This blueprint solution was constructed and tested in Lenovo's AI lab located in their US headquarters in Mooresville, North Carolina. The very latest in technology was used, including cutting-edge AI servers equipped with GPUs, storage systems, and advanced data center switches.
My name is Martin Hiegel, and I'm responsible for the enterprise AI and our HPC business globally at Lenovo. In my 20 years at the company, this is the most exciting time I have seen. The transformation is amazing that's happening in the market right now. AI is a crucial component, crucial application of the current and future data centers. Both Nokia and Lenovo are technology leaders in their respective areas. And so this partnership shows how important it is to have leaders in server and storage and leaders in networking come together to provide a secure, a reliable, and a scalable infrastructure to our customers.
In a sovereign AI system, its development, control, and deployment is contained within the jurisdiction of a specific nation, enterprise, or organization. The goal is to ensure its independence from foreign technologies, platforms, influence, as well as compliance with government or industry regulations.
Data sovereignty is also about creating security regulations and control over that data.
Lenovo and Nokia introduce its high-performance and scalable AI pod unit solution that allows service providers, governments, and enterprises to quickly deploy and turn up new AI applications and workloads wherever they are needed. The basic AI pod unit consists of high-performance AI GPU servers, storage systems, and management equipment together with a design-optimized switching network. The AI pod units can be scaled out to support hundreds of servers and petabytes of storage.
Hi, I'm Amit. I work in technical pre-sales and business development in Nokia. I work very closely with global partners like Lenovo, as well as channel partners across North America. And I also focus a lot on AI and HPC segment. We have been working closely with Lenovo for the past few months to put together an AI cluster and test it. We wanted to develop a solution that is easy to deploy with simplicity and reliability at the end customer side. So we developed these bundled solutions, and we have successfully tested and validated our Lenovo Nokia Sovereign AI validated design.
I'm Jared Upton. I run the AI Center of Excellence lab here in the Mooresville Lenovo headquarters. The hardware was the 289 platform. The server itself has 8 GPUs and is capable of 800 gigabit speeds. But in this instance, industry standard is 400 gigabits on the back-end networking. We accomplished that through rate easily on the Nokia switching that we have in place, and we integrated a little bit of DDN network attached storage. So it integrates all the major components of a total solution.
Let's look into the details of this validated design blueprint solution to understand more about its components and how it works. The Lenovo Nokia Validated Design Reference Architecture is composed of 3 main networking segments: the backend network, the backend storage network, and the combined front-end and management network. The backend scale-out network supports GPU to GPU connectivity. It's represented by Lenovo air-cooled AI GPU servers that host AMD Instinct GPUs and 400 gig NICs that are interconnected with Nokia high-performance Broadcom Tomahawk switches. The backend storage network is represented by Nokia high-performance Trident switches connected to Lenovo GPU servers and DDN storage nodes. Lastly, the converged front-end and in-band management network is represented by Lenovo GPU and management servers connected through Nokia Trident switches. To meet the network and performance requirements for sovereign AI model training, a rail-optimized back-end stripe design was used. In this back-end rail stripe design, each of the 8 GPUs in the server is dedicated a 400 gig port on the leaf switch and assigned its own IPv6 address. This design ensures that only a single hop is needed for GPU to GPU inter-server communication. Nokia's EDA, event-driven automation platform, was used to simplify the configuration, validation, and operational aspects of managing an AI cluster. The platform's AI backend application was used in all aspects of design, configuration, and deployment of the backend fabric, including multi-tiered architectures, multi-tenancy, IP addressing, and network parameter settings, such as for congestion avoidance and traffic prioritization.
The test that was conducted was industry standard benchmark suite called MLPerf. This is run by an organization called ML Commons. It tests inference and training for AI platforms. And this is an open source benchmark, so anybody can run it.
Lenovo and Nokia ran perf tests for standard RoCE v2 packet sizes ranging from 256 to 4096 bytes. The results shown are the average bidirectional bandwidth achieved across 400 gigabit interfaces. The results met or exceeded industry standards. Perf tests were also run for RoCE v2 maximum MTU packet size of 4096 bytes. The results shown are the average bidirectional bandwidth achieved across 400 gigabit interfaces. These results also met or exceeded industry standards. ML Commons benchmark testing was run on the performance of a 70 billion Llama 2 training and inference models that measured both throughput and latency metrics.
The test results were exceptional. Not only were we able to achieve the desired results, in a lot of cases we exceeded the industry standards. Nokia is a very open platform, so it integrates very easily, and we were able to accomplish everything and even exceed benchmarking goals with the Nokia switching.
We have performed different types of tests in this lab. We have performed iPerf tests, RICL tests, as well as MLPerf tests. All the results are at par or exceed the industry standards. With respect to MLPerf, we have done inference as well as training tests, and we can see the results from other runs of the industry on mlcommons.org, and the results are comparable and sometimes even exceed those results.
This validated design essentially brings that end-to-end, fully validated, certified solution that addresses different customer demands, addresses different use cases across different market segments, and helps our customers deploy AI with ease. Our validated solution gives us a credible, proven, and scalable blueprint that customers can trust. It opens the door to faster go-to-market, execution, deeper customer engagement, and stronger positioning against competitors.
Nokia and Lenovo are just getting started. This design validation testing will continue to progress and keep pace with the evolution of data center networking for AI. Our partnership goal is to stay on top of the innovation curve and be able to earn your confidence in our pre-integrated, verified solutions that aligns with your own AI aspirations.